It's my pleasure to welcome you here to my session on big data processing with Spark and .NET. My name is Michael Rees. I'm a program manager on the Azure Big Data team, working among other things on Synapse and also on .NET support in Spark. If you want to contact me, there's my Twitter handle here, my email alias. Also, if you want to tweet about this session or .NET for Spark in general, please use these hashtags. These are the ones that we are kind of monitoring. And the link that you see at the bottom is where you basically then will be able to get the recording, the slides for download, and can start chatting on the messaging board. So let's start quickly and talk about what is Apache Spark for those few of you that don't know yet. So Apache Spark is an open source fast analytic engine for doing big data transformation and machine learning. It is designed to be efficient by giving you a general computation graph that goes beyond the general MapReduce paradigm that was originally kind of the standard paradigm for doing big data processing. And it provides in-memory computing primitives to, again, kind of improve the performance of your processing of your big data pipelines. It is designed to give you the ability to scale out your code and write in the language of your choice. So it has rich APIs in Java, Scala, Python, R, Spark SQL, and now, obviously, as part of this presentation, you will see also in .NET. And it gives you the ability to do batch processing, streaming, and even interactive analysis. And I will show you the batch processing and interactive part as part of this presentation as well. It is available in Azure now via Azure Synapse, which I will be using for my demos, Azure HD Insight, Azure Databricks, and you can also build your own Spark clusters using Kubernetes containers in an IaaS environment. About a year ago, we had a .NET developer survey where we asked about 1,000 of our .NET developers about a variety of things, including what is their interest level in doing big data processing and specifically Spark. And 70% of the people replying to the survey told us that they have interest in Apache Spark and .NET at the same time. The reason why that is because they want to tap into what the open source ecosystem provides them with. They want to be able to use the libraries that people might have developed already in that context. They might want to be able to just go online and search for code samples on Stack Overflow or so. And there is a lot of such information available online. And they want to be able to hire talent. If you have a big data developer that comes off fresh from college, for example, it's most likely that they have experience with Spark. So that's kind of why you want to do that. So if you have your Spark programmers, however, right now the main choices are Scala and Python. So as a .NET developer, you're kind of locked out from this big data processing space because there is no .NET support in these open source solutions. And of course, that matters because you have already existing business logic that you have in .NET that you might want to scale out over your data, or you want to have existing developers that are .NET experts and you want to leverage them and you want to move them into the next phase of doing big data development. So that's why adding .NET support through Spark actually makes a lot of sense because it kind of unblocks these use cases from happening. So now you can take your business logic and scale it out. You can use your existing .NET expertise and use it in a big data processing environment. So the goal for .NET support in Spark is to make it easy for .NET developers to get a first-class experience when working with Apache Spark. We don't want to aim to convert Python and Scala programmers necessarily. I mean, if they want to come and switch, that's fine, but that's not the main goal of this endeavor. One thing that we have been doing is that we have been developing it in the open from the start, so it's part of our .NET Foundation. So you can go to the .NET Foundation website or its GitHub and work on it, and you can contribute. We have already a couple of external customers contributing capabilities to it. Currently we are releasing version 06. We have provided Spark project improvement proposal to Apache to integrate it into Apache once we are closer to being complete. And we have already done a lot of contributions to fundamental open source projects such as Apache Spark Core, Apache Arrow, pickling libraries, etc., to make the experiences better, not just for us, but for other components as well. Now, the .NET support in Spark provides full spectrum Spark support. What that means is that you can take your Spark data frames with Spark SQL and use them in the context of a .NET program. And I will show you that in a minute. You can also use .NET user-defined functions and call them from within your Spark calls as well, including, for example, Delta Lake support. So we have Delta Lake libraries that we are shipping with the .NET Spark support as well. It is based on the .NET Standard 2.0, so that means you can use it both on Spark installations running on Linux, as well as Spark installations running on Windows. And we'll actually see that in a minute as well. And it includes C# support and F# support using the standard libraries that we are providing. We give you batch and streaming, so we do give you Spark streaming, structured streaming support, and we support all the natively out of Spark supported data sources. So if you can say Spark dot load of a certain data format, you can also say that using Spark.net. And we give you kind of data science access, so we integrate with ML.NET, and we give you interactive notebook experience with a C# REPL experience. And that's actually part of the demos that I will be showing you in a bit. And finally, we have done a lot of work to improve performance. So we did a lot of work using Arrow as the interchange format to make data transfer between the JVM and the .NET side faster. We added hardware support for hardware vectorization if you're using .NET Core 3 or 3.1. So there's a lot of work that we have done there. Actually, with the result that we are now about 5 to 10% faster in our benchmarks than if we would do the same code running in Python. We have a lot of examples at our GitHub site, so I'm always pointing you there to kind of get some more things going. So here's just a quick overview of some of the capabilities that we have been adding over the last couple of releases in Spark 0.6. The link is clickable, so if you download the slide deck, you can use that. And I would like to point out some of these things have been contributed by our community. Some of the things like the Delta table support is done by our team. Now, let me quickly show you a little bit how these two languages compare. On the left-hand side, you see the Scala code. On the right-hand side, you see the .NET code. Let me zoom in a little bit, which you don't see. That's not good. So tell me a little bit what you kind of see in terms of differences. They look very much the same. Now, the syntax is what we call dangerously copy-paste friendly. The reason for that is if you go today and look for a solution online, let's say I did that for my demos. I needed to look up something and said, well, how do I do that in Spark? I found the Scala or Python code. I copied it over into my .NET solution, and I quickly did my uppercase adjustment, my equal sign adjustments for comparisons, some small adjustments around referring to column names, etc., and was able to actually have the code running in like a minute or two after copying it. That's the reason why we are basically following so closely to the .NET and Scala experiences. So now let me show you quickly the demos. In the first demo, I take a tweet file that I downloaded about my tweets, and I use a .NET for Apache Spark program, and then I execute that on my local machine, and I basically show the result on my console. In the second example, I uploaded many of those tweet files up into my Azure Data Lake storage account. I'm using .NET Apache Spark to do some complex data preparation using a Spark cluster in Azure Synapse. And that creates me Spark tables. And then I have a notebook that I use to actually analyze and get some interesting insights over the data that I have uploaded and processed. So now let's go over and actually show you the code here. First, let me show you the data. And let me change the display setting here. Apparently, okay. Can I switch over? Duplicate, where do I do that here? Yeah. Okay, sorry about that. So let me zoom in here quickly and show you. So this is the input data that I have. I have a column of date, the column of time, who was tweeting, and what the tweet was. And then the tweets, of course, has mentions and references and things like that. So the program that I'm writing right now is I'm extracting and analyzing some of these tweets. And so I basically have Visual Studio here, and here I have some the code that actually creates the table. What I use for this is I basically import or use two new namespaces, Microsoft Spark.SQL and Spark.SQL functions, and I add a NuGet package that I can just download from NuGet.org, which is the Microsoft.Spark.NET for Apache Spark version. So that's the latest one that you can get up there. And that's all I need to basically code in here and then run this locally. So the code itself is actually, in this case, I think the count tweets. So let me show you that. The Spark code is very simple. I start out with creating a Spark session, which gives me basically the Spark context. It creates the cluster, so to speak. And then I go and say, read the data. Here's the schema for the CSV file, format CSV from the input file. And then I want to kind of count the number of tweets per author. So what I do here is I say group tweets is a data frame that gets created out of the tweets data frame that I have created up here by reading the data. Group by author, count, and order by descending count. So this is just simple Spark .NET code that looks very similar to the Scala code that you would be running otherwise. So I would compile, build the project, and then I go and run it. So in this case, let me see. No, that's the other one here. In this case, I submit it locally. So what I use here is I have my Spark submit command. I give the class of my Spark.NET runner of my Spark 0.6 .NET package. And then I provide the .NET and the DLL that I want to run on it. So if I go and run this, it will now start the Spark cluster up on my local machine and process it. We'll get back to that later. Let me now switch over quickly to show you a little bit more of the data prep and analysis earlier. So that's going to run a little bit on my machine here. So let's go and take a look at the actual data preparation code that I'm going to show you. So in this case, I'm actually running it on the cluster. So the input files that I give you are these ABFS URLs pointing to files in your Azure Data Lake Generation 2 account. I use a wildcard here because I have more than one CSV file, and it actually allows me to do that. I need to do some processing. I want to be able to extract the mentions and the topics inside those tweets. So I wrote here .NET Lambda function that basically takes a string that is a tweet and extracts words that have a certain prefix, like a hashtag or an @ sign. I will be using that as a user-defined function a little bit later. If I scroll down here into the code, you notice again I create my Spark session. Then I go and read from my input files. Now there are more than one file that I'm reading here. I do some unification. I remove some duplicates here because the input files contain duplicates. And then the next thing is quite kind of interesting. So on this line here, I am now creating user-defined functions that I will be using in my Spark program that are written in .NET. In particular, what I do is I'm registering as a UDF, that's done here, that takes an input string, which is a tweet, and it returns an IEnumerable of string. So note here, I'm using native C# types. We actually don't have to use Spark types or whatever. We actually will take care of that. Spark.net will take care of that. And then I basically extract, for mentions, I extract with the @ sign, and for topics, I extract with the hash sign. And then that's what I'm doing down here. I basically create another data frame, mention and topics, where I go select the author. I select their tweets and their mentions and their topics out of the tweets. Now I have a data frame. I want to be able to get that data into a way that is prepared so other people, let's say data analysts and so on, or data scientists, can query that data. So instead of then having to share that code with them all the time, what I'm doing now is I'm going and creating a database inside my Synapse workspace that you see here. So I say create database, tweet analysis, use tweet analysis. Then I factor the mentions and the mentions out. In this case, since each of the mentions and the topics are an array of string, I have to replace them and pivot them into one row per mention and one row per topic. That's done with this Spark command, which says replace the mention column with an explosion of the mention array. So it's basically pivoting this into one row per item inside the array. I do that for mentions and for tweets, and then I save them as tables. Now you will notice that I say here mentions repartition 1. The data is not that big that I need to have my data partitioned bigly. But the thing is because I have a lot of input files, etc., the standard Spark processing is that it scales out. So it would give me 200 very small files, which is not what I want. I want one big file. So that's why I repartition here. And then I write it as tables. So I have done that. And I have run that already, but I show you how I was submitting it inside the Synapse Studio. So if I go here, we have the Synapse Studio that you probably have seen before. Just to show you, here is the data that I have uploaded. So these are all the tweet files that we had. And now I want to run this. So when I want to run this as a batch job, in here, build again. Once it's built for my local Windows machine. So now I have to go and actually build it a release version for running on basically Ubuntu Linux, which is what we are running Synapse in. So what I do there is I go into my command prompt and just say .NET publish, and publish that project into an Ubuntu Linux code version. I then go into the corresponding folder that created it, the publish folder, which contains this code. And what I do is I go and basically zip that all up and upload it into the data lake so I can reference it up there during my submission. So in the submission itself, it looks like this. And let me go in. This is our general Spark job submission API for batch jobs. Now, I have to tell you that this will improve dramatically in the next couple of weeks and months. Because, for example, we already have preloaded the Spark.NET runtime inside the Synapse Spark clusters. So I would not have to actually define that here, but the submission process currently still requires it here. And then in the command line argument, I actually say which command, which program I want to run, which is my .NET program that has been now compiled for Linux. And I say which cluster it runs on, and then it basically runs. And you see down here, it kind of tells me it has been submitted, and then it shows you the history server URL where you can go and analyze the job. So now let's take a look at what I can do with this data. So I do have, by the way, I do have the same code also in a notebook that I will be sharing later on through our .NET GitHub website, so you can download it and play with it yourself as well. But now let's do some analysis. So as part of this, let me first introduce you to the REPL experience. So this is a notebook that I created over here on the develop side. And I have a tweet analysis notebook here. And it gives us interactive C#. So if you look at the first cell here, the first cell is just a C# expression. I have a string and I split it into words, basically. And this is actually executed dynamically inside the notebook. So no more compile, builds, running, console output. You can run this directly, interactively inside a notebook now using C# or F# if you want to. Now let's look a little bit about some analytics, what I want to do. The first thing is I run this, and I take my tweet analysis topics table that I had, and I take a look at how many distinct topics each person has been tweeting about. And then I order this in descending order. So you see here, I typed it in here, just standard Spark.NET code, execute it, and I get a result down here. And you will notice that I was, for example, number 4 in this list. Now I can also run Spark SQL in the same notebook, but because I'm in a .NET context, I have to use the Spark.SQL context here. So in this case, I go and count the distinct mentions that each person had. So you see M. Winkle was the top person being mentioned in that universe of tweets that I'm operating on. I can do more such interesting queries. Let's jump over some. Here, for example, I have a little bit more complex query that actually does a combination of Spark SQL to get the count of distinct tweets of authors that provided their tweets. I get the mention counts for all. I use a with common table expression in this Spark SQL query to be able to delete, to map renames of tweet handles. And then I use a normal Spark.NET expression down here to then do the count and show the order by. And do a join to give you the influencer score of a number of mentions divided by the number of tweets. So here's the job that I run just a little bit earlier, 12 seconds. And here is the result. So you will notice that Savine R has the highest influence because while he only tweeted 20 times, he was mentioned 102 times. So a lot of people seem to be feeling he's important enough that he needs to be mentioned. Now, to show you the last part of the demo here, we can also do notebook visualizations. So, and in two ways. The first way is that I can actually build my own formatters. So in this case, the code that I have here is writing a special formatter for a SQL data frame, which is the object that gets returned. What this does is it basically does some pretty printing instead of that ASCII thing that you've seen for tables. I do now a pretty printing of my data frame. And so what I do down here is, in the next frame, I'm now going and show the top 5 quarterly tweet topics that I tweeted about in my Twitter lifespan. So this is calculated here with this Spark SQL query. So you see I get my topics, clean them up, then calculate them quarterly. You will notice there are like functions in here such as quarter of date and year of date. These are built-in Spark functions that you can use either from Spark SQL or Spark.net. And then I basically show this both in the ASCII version and using my new formatter that I have below. So let's go down here. And now you see here, this is the new formatting that I just created. So this is basically me using .NET code in my .NET notebook to show some cool formalization of a data frame that I created with Spark.net. And now I can go do even more. We have integrated into the notebook experience Plotly, which is a standard plotting library. Let me get my thing back here. So this is basically what I'm doing here now. So I'm taking that table format that I just shown you earlier and try to visualize it a little bit nicer, because it only, like, seeing it in tabular format is not as impressive as seeing a graph on it and being able to do some insight. So what I'm doing now is I basically go and use that Plotly library to go through my row set and do the visualization. Let me run that quickly, just to show you that I'm not just showing you code that has been done earlier. And it already finished. And down here is now the visualization. So these are the quarterly tweets. If we zoom in, you will notice I have like these 3 spikes. The first spike was back in 2010, 11 to 12. If I hover over the columns here, let me zoom in a little bit, you will notice there's a lot of SQL Server type and XML XQuery type tweets that I was tweeting about. That's when I was working on the Beyond Relational theme in SQL Server. Then between 2015 and 16 and 18, there's a lot of like data lake and SQL, because that's when I was working on Azure Data Lake, so I was tweeting a lot about this. So what I've been tweeting about recently, well, I can go here, for example, the last bar, and you will notice I'm tweeting about Azure Synapse, and I'm tweeting about .NET for Spark. So you kind of see what I've been working on just by doing a little bit of data analysis quickly using Spark.net here. The UI is quite interesting. So for example, this is all active. So if I just want to see when I tweeted about .NET for Spark, I double click on it and the graph actually gives me that further integration. A very useful tool for like doing data exploration, doing data analysis, doing data science, etc. Okay, now let me just show you what happened here. So my job finished. If I go and look at result.txt, you will see here this actually failed, which happens to be because I was running it against the, I think it didn't find the file or so. Sorry about that. But basically, you can run it locally as well. And by running it locally, you can do local debug before you actually submit it against the cluster, where debugging is a little bit harder to do. So let me go back to the presentation. and quickly wrap up. So what is happening if you run .NET Spark code? You have your data frame-based code, or you have your Spark SQL code that gets processed by .NET for Apache Spark, and it basically gives you this combined operator tree. So whether you do a count in Spark SQL or a count in Spark.NET, it gives you the same node inside that operator tree. It gets then basically deployed and executed. Now, if you did not define a .NET user-defined function, then the regular execution path is that it doesn't need any .NET runtime. So it will just execute this execution tree using the Scala JVM Spark implementation. If you have a user-defined function, then you get interrupt between Spark and .NET. That is going to be faster than the interrupt that you get between Spark and PySpark, for example. So we have done a lot of work to optimize that. As I mentioned, Spark.NET works everywhere. It works on any of the operating systems, and it works cross-cloud on Azure Synapse, Azure HD Inside Spark, on Azure and AWS Databricks, on AWS EMR Spark. On the first two, it's installed out of the box. For the second two, we have installation in kind of descriptions, documentations on our GitHub page. It's like 3 or 4 steps that you have to go through to make it available inside your Spark workers in these systems as well. We have a couple of things that we are looking to actually work on. We are, however, interested in hearing your feedback. So if you can go to the GitHub site and let us know what is the thing that is still missing for you. We will get very quickly normally and try to add it. And otherwise, I thank for your attention. Please engage with us. Here are a couple of useful links. The QR code will take you to the .NET GitHub site if you want to go and basically like us, enroll us, or whatever. We have a couple of videos that Brigitte from our team did on Channel 9 and YouTube. And obviously, it is available now in Azure Synapse, so you should go and check it out either there or HD Inside. And in the end, I hope you will love Spark and .NET together as we do. Thank you very much. This is the QR code, takes you to my slideshare.net page, so where you can find the slides already, so you don't have to wait. Thank you.